Today's lesson, we're going to talk about linear programming in 2 dimensions. So what's the linear programming? Linear programming deal with the finding maximum value of the profit functions or minimum value of cost functions. Objective functions is a function to be optimized. So example 1, it say find the maximum and minimum value of the objective functions. This is going to be objective functions subject to following constructions. So this is the outcomes that we're going to use to find what will be maximum and minimum value of these objective functions. So the first thing we wanted to do is graphing. We wanted to graph all this. And if you have previous lesson, you know how to graph system of linear inequalities. You should know how to do that. So you need to graph each of inequalities separately and then find the overlapping area, right? So we do 3y minus 2x is greater than 0. So for y, we will have 3y is greater than equals to positive 2x plus 0, where you don't need to write plus 0. When you divide both sides by 3, you will get y is greater than equals to 2 over 3x. So with that, when you're graphing, you're going to have 0 as y-intercept, and then you're going to have 2 over 3, so go up 2 and move 3 will be the point. Draw the solid straight lines. And since y value had to be greater than equals to, that will be above this line, right? So it will be above this line. And let's look for the other ones. We have y plus, you know what? We don't need to, we don't use to use different color here. So let me just use the black. Y plus 8x is smaller than equals to 52. Solving for y, I will get y is less than equals to negative 8x plus 52. So 52 is going to be the y-intercept. And from 52, you're going to have, so if this is 1, 2, your 52 is going to be way up here. Your 52 is going to be way up here. And then from there, using slopes to find the second point, from 52, you're going to go down 8 and move right 1. So if we have 52 somewhere right here, down 8, move right 1, it will be lying something like this, right? So since I'm not going to go up all the way here to graph, let me just graph it from here. So that will give you something like this. And y have to be smaller. So y have to smaller be this area. And then you wanted to do the third one. Third one is y minus 2x is less than equals to 2. So for y, you get 2x plus 2. So y-intercept is 2. And 2 over 1 means go up 2 and move right 1. So it will be that point. Draw the line, passing that 2 points will be something like that. And smaller, so it will be this area that you're going to color. So above this lines and the left side of this lines and below that area. right? So that will be somewhere here. But we're not done drawing the line. You have one more where x is greater than equals to 3. So your x3 is right here. So draw the line. And then greater, so it will be that area. So from this area, if you're looking for only the right side of x being 3, your solution area is going to be this. This is your solutions area. Oh, that's inequalities. So that's the first thing you wanted to do. Step 1, graph. Now step 2, find the coordinates of each corner point. We wanted to find all the corner points. And that corner points, you have 4. So this is one of the corner points. Let's name it 1. This is the second. Let's name 2. This is the third. That's 3. And this is going to be 4. So let's see if we can find all that. So in order to find point 1, you're going to use the second equations. This is the second equations, right? Second equations with the third equations. So intersection of those two. So intersection of those two will give me points 1. So it will be y equals to negative 8x plus 52 and y equals to 2x plus 2. When we solve for let them equals to each other, because both of the equations are equals to y. So we should be able to make them equals to each other. So it will be negative 8x plus 52 equals to 2x plus 2. Solve for 8. Let's subtract 2x from both sides. I get negative 10x. Subtract 52 from both sides. I get negative 50. And when you're dividing both sides by negative 10, you get 5. Using that, we should be able to find your y value. Will be 2 times 5 plus 2, which is going to be 12. So that first point is going to be 5 and 12. That's the point 1. Using the same method, we're going to find the point 2. Point 2, you're going to use what? X is greater than equals to 3, so we're going to use x equals to 3. And then we're going to use this equations, which is going to be y equals to 2x plus 2. So when you let x equals to 3 here, you will get 6 plus 2, so it will be 8 for the y value, and x is 3, right? So the second point is going to be 3 and 8. And point 3, you're going to use line x equals to 3 with y equals to 2 over 3x. Here, we get x equals to 3, and when we replace 3 here, it will give you 2 over 3 times 3, which is going to be 2. So the third point is going to be 3 and 2. And point 4 is going to use y equals to 2 over 3x, and y equals to negative 8x plus 52. So when they, because they are equals to both, equation equals to y, let both equation equals 2, so that we will have only one variable. You're going to move negative 8x to other side, which gives you negative 8x become 24 over 3, right? So this is same as adding 24 over 3x. That gives me 26 over 3x equals to 52. When you multiply both sides by 3 over 26 to isolate x by itself, I will get x is equals to 6. When you replace that into y equals to 2 over 3 times 6, your y value is going to be 4. So the fourth points will have 6 and 4 as the coordinations. Now, the last one you wanted to do, step 3, is trying to plug in all these 4 points, into our equations and see which one gives you minimums and which one gives you maximum. Okay, so we will plug into the equations. Let's try that. So we will have points. And we will test it in the objective equations. 5x plus 2y. The first points we will try is 5 and 12, and then 3 and 8, 3 and 2, and 6 and 4, right? By order. So when I plug in z equals to 5 times 5 plus 2 times 12, I will get 49. And then when I replace 5 times 3 plus 2 times 8, I get 31. I have 5 times 3 plus 2 times 2, I get 19. And then the last one, 5 times 6 plus 2 times 4. I have 38. So the one with the highest value, this is the highest value. So this point right here, this is going to give me maximum. And the smallest value right here, this is going to give me my minimum. So it depends on what types of word problems that you're going to use. If it's going to be profit, then you wanted to pick the maximums. If it's the cost, then you wanted to pick the minimums. So that's how you're going to use the linear programming to solve problems like this. Example B, we have the given equations subject to following conditions. So again, first thing we wanted to do, we wanted to graph. We wanted to graph them so we can find all the connecting points, right? So we will graph 3x plus 2y is less than or equal to 6. So for y, minus 3x plus 6 divided by 2 will be negative 3 over 2x plus 3 is what you're going to have. And I'm going to solve for all of them first before I graph it. And I have negative 2x plus 4y is less than equals to 8. 4y is less than equals to plus 2x. You're moving negative 2x to the other side, become positive 2x plus 8. When you're dividing both sides by 4, you get 1 over 2x and plus 2. So this one will be y-intercept 2, slope is 1/2. You also have x plus y is greater than equals to 1. All of them look like have an equal sign, so this is all solid straight line, where y is greater than equals to negative x plus 1. And then we have x is greater than 0, y is greater than 0. So x greater than 0, y greater than 0, that's looking at only this area. So first quadrant, right? So using these two informations, we already narrow down into the first quadrant. Now let's look at all these 3 different equations in a graph. Y is less than equals to negative 3 over 2x plus 3. Your y-intercept is 3. 1, 2, 3. And then you go down 3 from this point. You go down 3, move right 2 will be that. Draw the straight line. This is y is less than equals to negative 3 over 2x plus 3. And then the second one is going to be, and which area? Area is going to be less than. So this is this side, right? So it had to be first quadrant, right? Because there's two conditions. And on this side, so we're looking at very small possible area right now, right? That's the area we're reduced to. Let me erase that because I wanted to draw the line for the second inequality. Your y-intercept is 2. And then go down, go up 1, move right 2 will give you this point. Draw the straight line. And this is going to be y is less than equals to 1/2 x plus 2, right? And smaller. So smaller will be this side. So now we reduce to this area, right? Let's do one more line. Y-intercept is 1 here. Let's do that, right? Y-intercept is 1 here. And slope is negative 1, which is negative 1 over 1. So go down 1, move 1 will be this point. Draw the straight line, passing. That's going to be y is greater than equals to negative x plus 1. So greater, so it will be this area that we were coloring. So the area that we have is going to be only this. Where is the point? You have point 1, point 2, 3, 4, 5 points, right? Of that shape. So let's name, I don't know, this one as the first, second, third, fourth, and fifth point. In order to find the first point, you're going to use y equals to 0 and y equals to negative x plus 1. The reason we're using equation is because the line is what we're looking at right now. In order to find that point, we're looking at the line. So this will give you x equals to y equals to 0. Right? Y equals to 0. When you replace y equals to 0 here, when this y equals to 0, your x is going to become subtract 1, so x is going to be 1. So you will have 1 and 0. And point 2, you will have y equals to 0 and y equals to negative 3 over 2x plus 3. So again, your y will be 0 when you replace it here. Negative 3 over 2x. Let's move that to the other side, so it will be negative 3. And then you multiply both sides by negative 2/3 to isolate x, negative 2/3. It gives you x equals to 2, right? Because it's to cancel out 2. So x will be 2. And then let's find third point. Third point, you have y equals 2. This is third point right here. So intersection is going to be with this 2 line, right? So y equals to 1/2 x plus 2. And y equals to negative 3 over 2x plus 3. When you let them equals to each other, because they both equals to y. And solve for x, right? Let's do subtracting 2 so that you can put number without the variable on the right side. And you're going to add 3 over 2 on both sides, add 3 over 2, so that you will have number with the variable on the left side. You will get 4 over 2, and you will get positive 1 on the other side. This is 2x equals to 1, so x should be equals to 1/2. When you replace this into one of your equations, so let's replace it into the first one. 1/2 plus 2, this is 1/4 plus 2. And we know that 2 is going to be 8 over 4. So when you add them, you will get 9 over 4. So the points you get, so this is the first point, second point, third points you get is x 1/2, y 9 over 4. And then we have 2 more, right? Let's find fourth one. Fourth one is right here when x is equals to 0. And y equals to 1/2 x plus 2. So this one gives you points of x 0. When this becomes 0, that disappears, so it will be just 2 remains, right? So that will be the fourth point. And fifth point. Fifth point is going to be this one right here, which is again x equals to 0. And y equals to negative x plus 1. This will get x 0 and y 1. Right? So now my third step is going to be testing all these points in the given equations. Points and equations. So first point, second point, third point, fourth, and fifth. Let's see what I get. When I replace this here, 2 times 1 plus 5 times 0, I will get 2. This one I will have 2 times 2 plus 5 times 0, I will get 4. 2 times 1/2 plus 5 times 9 over 4, I get 1 plus, do the multiplication, so it will be 45 over 4. 1 become 4 over 4. It will be 49 over 4, which is somewhere close to 12.25. I need to compare with the other numbers, so I like to have a decimals. The fourth one will be 2 times 0 plus 5 times 2, which is 10. And 2 times 0 plus 5 times 1 will be 5. So look like this is going to be my maximum point. And then smallest value is this one right here, which is my minimum. Minimum points and maximum points. And this is how you're going to solve example B. So before we go over the word problem, actual problems to create all this concept, right? Problems. From the word problems, I wanted to also mention you could have example where it will have minimum points but no maximums. So when do we not going to have a maximum? We're not going to have a maximum when your graph area is going to be open up. So because this is open up, it's not boxed in. The area is not inside. Its area is open one side. In this case, you're not going to have maximum points. You will only have minimum points with the smaller values. So if you want me to go over the full of these problems or next one, email me and I'll be able to create one and email it to you. Otherwise, we're going to continue to the word problems now. Okay, let's look at example 3. So, 4-H club member raise goats and pig. They want to raise no more than 16 animals, include no more than 10 goats. And she spent $25 to raise her goats and $75 to raise a pig. And she had a total of 900 available. Right, 900. So this is all important information. So in order to maximize the profit, and the goat produced profit of $14. So goats, $14 profit. And pig profit is $40. How are we going to find the maximum profit? So we're going to use the examples that we did before. So in order to do that, we should be able to create some inequalities, right? So the first thing I wanted to do is we're going to let unknown variable equals to represent some of the wording. So I'm going to say X is going to be number of goats. And then Y will be number of pig. Because we need to know how many goats and how many pigs we're going to have maximum profit, right? And the first inequalities that I can use is no more than 16 animals, right? So you don't want it to have more than 16. So we should be able to create X plus Y should be less than equals to 16. So when you're adding number of goats and number of pig, it should be less than equals to 16 because it's a no more than 16. 16 will be the maximum. And then it's a also no more than 10 goats. So X is representing number of goats. So X should be let me write it under. X should be less than equals to 10. And what else we have? We have $25 to raise a goat and $75 to raise a pig. So when you're multiplying number of goats times 25, that will give you the amounts that she's going to spend to purchase the goats. And a number of pig times 75 will give you the amount that she should be able to spend to buy the pig. And that should be less than $900, right? Because that's available amount that she have. So you should be able to do 25 times X. This is total amounts to purchase the goat. And plus 75 times Y should be smaller than equals to 900, right? So now I have 3 inequalities. From what's given. And then the equations you wanted to create is going to be coming from right here. This is the profit equations. It said I'm going to use the Z for the profit. And when you get $14 of profit from goats, you're going to do 14 times X to find out total profit, plus 40 times Y to get total profit from the pig, right? This is going to be the equations to create a profit, your margins. Let's see if we can create some of inequality for y is equals to, right? Just changing the format, so we should be able to graph the line easily. So the first equations I should be able to graph as or solve as y is less than equals to negative x plus 16, right? Just move x to the other side. This is already y is less than equals to 10. You don't need to actually switch. This one, I should be able to divide everything by 25. So let's just divide everything by 25. I get x plus 3y is less than equals to 36. And then when you wanted to solve for y, you will get 3y is less than equals to negative x plus 36, and divide everything by 3. Y will be less than equals to negative 1/3 x plus 12. So I created, I have 3 inequalities that I should be able to mark it in the graph line. So let me see if I can graph it. I have y-axis and x-axis. The first one, my y-intercept is 16. So let's say this is 16. And then slope negative 1 means go down 1, move right 1. So it'll be that point. So I will have your straight line for the first inequality look like that. And then the second equation, inequality x is less than equals to 10. So if we have 10, somewhere right here, let's say this is 10. So x is less than equals to 10. So the area should be on the left side of that vertical x, the graph, right? And then what about this one? This line, it should be less than, so it will be under this straight line, but also on the left side of vertical line. So it will be just this area right now, right? What about the third one? Let's look for third line. Third line, you have x-intercept 12. So x-intercept 12 somewhere right here. Let's say this is 12. And then go down 1, move right 3. So somewhere right here. Draw the straight line. And this is going to be y is less than or equal to negative 1/3 x plus 12. And then last answer will be under, right? So it's under here. So when you're coloring the solutions, the area is going to be this, right? Why is it not all this area? Because you're buying pig and goats, and you cannot buy negative values. So even though they didn't mention this as inequality, you cannot color anything that's the negative numbers. So it means no negative x values, no negative y values. So that's why it had to be inside y-axis and x-axis. So that's the graph you end up getting, right? So if you wanted to find the points, this is the first point. This is another one right there, and there. You have total of 5 points, right? So let me write all those 5 points. Once you have all those 5 points, right? I find all those 5 points. And don't forget how to find these 5 points by connecting those inequalities into equations, right? So, and then you're going to replace this value into the equations. And it gives you 0 value. And then you will have 40 times 12, so it will be 480. This is going to be 14 times 10, so it will be 140. 14 times 10 plus 40 times 6, you get 380. 14 times 6 plus 10 times 40, you get 484. So the maximum, this is going to be your maximum value. So in order to get maximum profit, you wanted to buy 6, what's the X was it? X was goats, 6 goats and 10 pig, right? 6 goats and 10 pigs will produce our maximum profit in that problems. So this is how you're going to use linear programming to find the maximum profit. Let's look at one more example. This example is the manager desired the greatest storage capacity within the limitations. The limitation is going to be the budget of 560 and the room for only 72 square feet of the cabinets. And then condition he have is two different options of the cabinet. One is cost $40, requires 6 square feet of floor space and holds 8 cubic feet of file. And then second choice is cost $80, require 8 square feet of floor space and holds 12 cubic feet. So what we're going to do is trying to create some inequalities, right? In order to create our inequalities, we wanted to give the variables. Let's create a variable. The first variable I have is x value. X value is going to be number of the first cabinet. And y is going to be number of the second cabinet. The first cabinet price was 40, second cabinet price was 80, and then budget is 560. So when you're multiplying number of the cabinet times the price for both and add them up, it should be less than equals to the budget, right? And you should be able to change this or simplify this and solve for y. So you will have, let's move 40x to the other side. It will be negative 40x plus 560 and dividing by 80, right? This will give you negative 1 over 2x plus 7, right? And then second inequality, I will have the space, right? So it will be 6 square feet times the number of first cabinet plus 8 square feet times the number of second cabinet should be less than equals to space available, which is 72 square feet, right? And let's simplify this or solve for y. You will have less than equals to negative 6x plus 72, and when you're dividing by 8, you get negative 3 over 4x plus 9. And don't forget, you're purchasing the cabinet. So the number of the first cabinet cannot be negative. So it had to be greater than equals to 0. And number of the second cabinet also have to be greater than equals to 0. So when you're graphing this, we only need first quadrants because had to be greater than equals to 0 for x, greater than equals to 0 for x. So everything had to be in first quadrant, right? Let's draw the first inequality. First inequality, y-intercept 7. And then slope is negative 1 over 2. So go down 1 and move right 2. Will be somewhere right there. So draw the straight line. And then the second inequality is going to be y-intercept 9, and go down 3, negative 3, and move right 4. Go down 3, move right 4, should be somewhere right here, and draw the straight line, right? So your graph is going to be this. And then points that you're looking for is this points, that points, this points, and that point. And if you draw this in the any graphing tools, actually the points that you need to find out is this points. Everything else you should be able to read it in a graphing tools. Or if you're just hand graphed, then you actually need to find the intercept of those two lines, like we did it from previous problems. So the points that I have is 0, 0, and 12, 0, and then this is 8 and 3, and 0 and 7. we're going to input that points into the equations. So what's the equations? We didn't find the equations yet. So let's look at our equations. The maximum storage capacities, right, is going to be 8 times, because it holds 8 cubic feet of files and 12 cubic feet of the file. This is the capacity of each cabinet. So we'll do 8x plus 12y should be the maximum. So we're trying to find the maximum. So let's plug in to that equations. This is going to be 0, right? Because xy will be 0. And this is going to be 12 times 8. 12 times 8 is going to be 96. And this is 8 times 8 plus 12 times 3 is 100. And 7 times 12 is going to be 84. So it looks like this is going to be maximum. So this is going to be maximum, 8 and 3. This means we are going to purchase 8 of the first cabinet and 3 of the second cabinet.